whenever an atom forms a compound, its goal is to get a full, stable outer shell of electrons. As we know, that means it follows the pattern of 2, 8, 8. 2 electrons in the first shell means it's full, 8 electrons in the second shell means it's full, and 8 electrons in the third shell. In order to do this, they've got a few different options. They can form an ion, which involves gaining or losing electrons, which is great, but what if you want to bond a non-metal with another non-metal? Well, non-metals, except for the noble gases, of course, when they form ions, they form negative ions. That means they gain electrons. So if they're reacting with another non-metal, so for example, hydrogen and hydrogen, oxygen with oxygen, carbon with carbon, carbon with oxygen makes carbon dioxide, they've got nowhere to get those electrons from. There are no metal ions present that will give up their electrons. So instead, what they have to do to make that full outer shell is they have to share their electrons. And a covalent bond is very simply a shared pair of electrons. What do I mean by that? Well, I've got an example here, which is 2 oxygen atoms. Now, you probably know oxygen is a diatomic molecule with the formula O2. It's like that because each oxygen has an electron structure of 2, 6. That's 8 electrons in total, a full first shell, but 6 in the outer shell. And in order to make a full outer shell, it needs to gain 2 electrons. If it's reacting with another oxygen, it doesn't have anywhere to get those extra electrons from, and both of the electrons want 2 extra electrons. So what we can do is they share, their outer shells overlap, and these electrons are shared between both oxygens. In this example, this is a double covalent bond, as shown here, because each covalent bond is one shared pair of electrons, and there are 2 pairs here. We draw them with these dot and cross diagrams to show which atom each electron came from, and if I count the outer shell electrons of each of these atoms now, I've got 1, 2, 3, 4, 5, 6. Remember that these both count for both, so 7, 8, so that's full. That's a happy oxygen atom. 1, 2, 3, 4, 5, 6, 7, 8. That's a full shell. That's a happy oxygen atom. That means they've both got full shells. They've got 2 shared pairs of electrons, giving it a double covalent bond. Each covalent bond is represented with a line. So each line that you see on a covalently bonded molecule represents one shared pair of electrons. So a double bond has 2. A hydrogen molecule has a single covalent bond which shares 2 electrons in total. Oxygen's got a double covalent bond which shares a total of 4 electrons, 2 pairs. Nitrogen is a very strongly bonded molecule, 3 covalent bonds, which is a total of 6 shared electrons. So we call the number of bonds that each atom can make its valency. So if we have a look at a compound, so a very common compound, water, if we draw on the outer shells only, just to make it simpler, we're not going to draw the inner shells. Hydrogen has 1 electron, which means that it's got 1 electron in its outer shell. It's only got 1 in total. If it wants to make a stable outer shell, if it wants to fill up its outer shell, it needs to gain 1 electron. It can, of course, lose 1 electron. That would make an ion. Hydrogen can make positive ions, but the oxygen needs it to, so it needs 2, sorry. So it will take 1 from each hydrogen, and it will also give 1 to each hydrogen to give it this shape here. So it's now got 1, 2, 3, 4, 5, 6, 7, 8, and each hydrogen has 2, so it has a full outer shell. So to recap, a covalent bond contains a shared pair of electrons. It happens between non-metals, and the finished product gives each atom a full outer shell. Thanks for watching.